In this video, we're going to summarize everything about eccentricity with conic sections. So conic sections, there's like a lot of different ways that you can define them, but there does exist a definition of the conic section. I'll just like explain it to you. So given a fixed point, so the focus, which we know all conic sections have, and a fixed line L, the directrix. So I think in this series we've only talked about the parabola having a directrix, but technically we could create a directrix, or there's a directrix that exists for any conic section. So given this fixed point and this fixed line, and a positive number e, which we've been talking about calculating, the set of all points P in the plane such that the distance of P from F equals E times the distance of P from the L, so the point from the directrix. So conic sections are over and over again. The thing I want you to take away from this is that conic sections are over and over defined as having to do with distances and fixing those distances in a certain way. And so without getting too far into the details, this is another way of looking at that, but it's that set of distances times the eccentricity. And this equation here defines a conic section of eccentricity E. And so now I just want to remind you of like the different types of eccentricity that are possible. So with a parabola, we never calculate eccentricity because the eccentricity is always equal to 1. And this can also be said for a circle. So for a circle, the eccentricity is also equal to just 0, so you don't have to calculate it. But for an ellipse, the eccentricity of an ellipse will fall between 0 and 1, not equal to 0, not equal to 1, because we know what happens when that happens. And then a hyperbola has eccentricity greater than 1. So this is just a really brief review of all of those eccentricities. And I want to just take a moment now to remind ourselves of how do we find the eccentricity for each conic section, because it's a little different depending on the conic section, right? So in this case, so the first thing that you're going to want to do if you're just asked to calculate general eccentricity is to identify what type of conic section you have. So this is, hopefully you know this, this is a hyperbola. So for a hyperbola, to calculate your E, you need to take C over A. And to calculate C, so the thing I always remember about this is that if like these go in opposite signs, so if this is a minus and this is a plus sign. So then I can calculate my E as 9 plus 4, which, oops, sorry, this is C squared. What am I doing? C squared. So my C is going to be equal to the square root of 13. Therefore, the eccentricity will be the square root of 13 over the square root of A, and A is whatever is under that first term. So square root of 9 is 3, so the eccentricity will be square root of 3 over 13. So moving on to the next one, so again, you have to first identify what type of conic section you have. So I only have a x squared term, so I can tell just by looking at this that this is a parabola. And so once you know it's a parabola, you don't have to do any other work to figure out the eccentricity. The eccentricity just equals 1, and that's it. Finally, for this last conic section, so you'll notice I have x plus 3 squared over 25 plus y minus 1 squared over 9 equals 1. So this is an ellipse. So once again, I find my eccentricity by taking C over A in this case. And so for my C squared is going to equal A squared minus B squared. Now the thing to remember with ellipses is that your A is always the larger of the two numbers. You should never have a C squared that is negative. So if you just ended up kind of being mindless with your calculation and you get a negative number for this, then you know you chose the wrong A. Okay, so this will be C squared equals 25 minus 9, which equals 16. So my C will just equal 4. So my E then is going to be 4 over 5. And so that's it. So just a really quick discussion of just to round out and summarize everything with eccentricity. So I will catch you guys in the next video.